Good morning, children. Welcome back. In the last class, in the last video, we discussed about the errors. Isn't it? What is error? While doing an experiment, there is a possibility of error, and what are the different types of error, and how can we rectify that error? How can we minimize error? That is the thing we discussed. So, to minimize the error or to avoid error, we have to calculate what is the amount of error happen in an observation or in an experiment. Okay, so you are doing an experiment and you are taking the value, you are getting the result, and you have to calculate how much in magnitude we have to find out what is the error occurred in our measurement. Is there any error? Is it a large quantity or is it a small quantity? So accordingly, we can go for the rectification. If the error is too small, what is it? We can percentage error is too small, we can neglect it. Okay. And if it is a little big magnitude, what is it? We can go for some adjustment. Or if it is a large one, what is it? We have to drop the experiment measurement and we have to go for the second time. Okay. So at that time, it is not error. We will call it as the mistake. Okay, so to calculate what is the error in your measurement, what is the percentage of error in your measurement, we have to go for this next topic, that is absolute error, relative error and percentage error. So here we have to find out the percentage error in an experiment. Okay, what is the percentage error? And to find out this percentage error, we have to know the relative error. And to find out the relative error, we have to go for the absolute error. Okay, but first we have to find out the absolute error, then relative error and then percentage error. Okay, so the quantity, physical quantity, we will represent with its actual value plus or minus. So the error may be plus value or a minus value. For example, that is you are getting your result is 3. Okay, and you are getting 3.1 or 2.9. Okay, from the correct value, if it is 3, it may be 3.1 or 2.9. So that variation is permitted. Okay, so plus or minus variation from the actual value, there will be a plus error or a minus error. So what is that error? Accordingly, we will represent the result. So we have to find out what is it. So for that, we are just revising the last year, your 10th standard experiment. That is Ohm's law. That is what is it? Find out the resistance. To find out the resistance of a given resistor by using the Ohm's law relationship. Isn't it? So you have the you are remembering the circuit diagram. Like in a resistor is there and a rheostat is connected, and parallel to this resistor, voltmeter is connected. Then there is a battery, a key and an ammeter connected, and adjusting the rheostat, we are getting the voltmeter reading and ammeter reading. We are tabulating that and using the relation R is equal to V by I, we are finding out the resistance. Isn't it? That was the experiment. So here I am taking that experiment and the final result only, that is the R value only I am considering. By using the relation V by I, you are getting R. Okay. So how many readings you have taken? Your teacher told you to take a minimum 5 readings. Right? 5 readings we have to take. So that is we discussed also to minimize error. That is the one of the method, taking more number of reading. Okay. So here I am just writing, that is first reading. In the first reading, the first measurement, you got R as 3 ohm. And the second one, it is, I am getting it as 2.8 ohm. And in the third reading, it is again coming as 3 ohm. And in the fourth reading, it is 3.1 ohm. And in the fifth reading, it is 3.2 ohm. Like this, 5 resistances we are getting. Then how did you write the result of this? The resistance of the given coil is. How did you find out? You found out the mean value of this. isn't it? Average of these quantities. You found out the average of this quantity. What is the average? How will you find out the average? Average is, what is it? R is equal to 3 plus 2.8 plus 3 plus 3.1 plus 3.2 divided by 5. Isn't it? Total divided by number of observations. 5. So how much it is? 3 plus 2.8 means 5.8 plus 3, 8.8 plus 3.1. Isn't it? So 11.9 plus 3, 15.1. So here it is 15.1 divided by 5. How much it is? 15.1 divided by 5. 5, 15, 3 times. 3.1, no 5. So we will put 0 here. Then it comes 10. In 10, how many 5s are there? There are 2 5s. So the resultant value is 3.02 ohm. So that is our result, isn't it? That is, we are considering that as the resistance of the resistor which provided you. So we will call it as the true value. Okay, this 3.02 is the actual value or the true value of the resistance here. Any physical quantity, what is it? Mean of the measurement will give you the true value or the actual value. So we can write true value is equal to mean of all the measurements. Okay, mean of all measurements. So if in general, from this we are generalizing. So in general, if A is the measured quantity or it is a physical quantity, if we are representing A as the physical quantity, and what is it? True value is equal to what? True value is equal to A average. So average of A is the true value of A. What is A? A is a physical quantity. For example, what is it? It may be force, it may be velocity, acceleration, anything. So in general, we are representing it as A. So what is the true value? What is its true value? It is equal to its average value. Okay, it is its average value. Then we have to find out what is absolute error. Absolute error. So now we got the true value. Next we have to find out the absolute error. So how will you find out absolute error? So what is absolute error? Next we have to find out absolute error. So how will you find out the absolute error? Come to this. Okay, same experiment, same set of readings. So absolute error is, here what is the true value? Here the true value is 3.02. So in the first measurement, absolute error, I am writing it as A. A stands for absolute error. Okay, absolute error is equal to, in the first measurement, absolute error is equal to true value. What is it? 3.02 minus measured value. So what is that? Absolute value is true value minus measured value. True value minus measured value. So in all the measurement, in each measurement there is absolute error. Okay, for all the measurement we can find out the absolute error. That is, what is the error occurred in each measurement, that we can find out. That is known as the absolute error. So in the first measurement, what is it? It is the true value minus measured value. So we got it as 3.02 minus 3. How much it is? It is 0.02 ohm. And for the second measurement, what is the absolute error? It is 3.02 minus 2.8. Isn't it? 3.02 minus 2.8. How much it is? 3.02 minus 2.8. That 2. Then how much? 2. Isn't it? So how much it is? 0.22 ohm. 0.22 ohm. And in the third measurement, what is the absolute error? It is again 2 minus 3. The third measurement, it is 3. So it is 3.02 minus 3, again 3.02 ohm. Then what is the fourth measurement? Fourth measurement absolute error is 3.02 minus 3.1. 3.02 minus 3.1. So how much it is? 3.02 minus 3.1? 3.1. So here it is 2 and here it is, how much it comes? Sorry, 3.1 minus, isn't it? 3.1 is the bigger quantity. Sorry, 3.1 is the bigger quantity. So 3.1 minus 3.02. How much it is? 8. Isn't it? 0.08. And is it plus or minus? It is minus 0.08 ohm. Isn't it? Bigger one is 3.1. Then the fifth one. Fifth measurement, what is the absolute error? It is 3.02 minus 3.2. Isn't it? That is 3.2 minus 3.02. So it is minus 0.18 ohm. So these are the absolute errors. These are the absolute errors. So how can we define absolute error? Absolute error is the true value minus measured value. Okay. And for all the measurement, what is it? We can find out what is the absolute error. Okay. So absolute error. So absolute error, we can represent it. It is the small quantity. Isn't it? Absolute error is the small quantity. So we can represent it as delta A. I told you delta stands for the small quantity. So delta A is equal to true value minus measured value. That is true value. We can write it as, it is the average value. We can write it as A average minus measured value. Measured value, we can write it as A1, A2, A3, A4, A5, etc. So here delta A1 is equal to A average minus A1. Delta A2 is equal to A average minus A2. Delta A3 is equal to A average minus A3. Delta A4 is equal to A average minus A4. And delta A5 is equal to A average minus A5. Okay, so this is the equations. Clear? So what we have done is, in the form of equation we wrote, that is the general representation, isn't it? So if A is the value, A is the measurement, and physical quantity, what is it? True value of A is A average, and the absolute error in each measurement is true value minus measured value. So for the first reading, the absolute error is this, second one this, third one this. Okay, so that is the average, actual value, true value and absolute error. Then next we have to find out the mean absolute error. These are the absolute errors we got, isn't it? This is for the first one, second one, third one, fourth one and fifth measurement. Absolute errors. So what will be the mean absolute error? Yes, it is the, and here it is negative and here also it is negative. So the mean absolute error is the mean value. So it is the mean value of what? Mean value of the magnitude of the absolute errors. Mean value of the magnitude of absolute errors. Why is that term magnitude I am specifying? Here you know this absolute error may be positive or negative. So we are not going for the positive or negative value. We are just considering its magnitude only. Okay, here these two quantities are negative. These two absolute errors are negative. So, no need to consider whether it is negative or positive. What is it? Just find out the mean of the magnitude. So, what is the absolute error? Sorry, mean absolute error is the mean of magnitude of absolute errors. Okay, mean of magnitude of absolute errors. That we will represent it by delta A bar. That is the mean value, delta A bar. So how much in this experiment, how much it is? 0.02 plus 0.22 plus 0.02 plus 0.08 plus 0.18 divided by 5. 18 divided by 5. These two are negative, but we don't consider it as negative, just the magnitude. Okay, so how much it is? Find out the mean value. How much it will come? Here it is 0.02, 0.22, again 0.02, 0.08, 0.18. Like, so 16, 18, 20, 22. 2 remaining. So it is 0.52 divided by 5. So how much it is? 0.124. Select 0.124 is the 0.104, not 24, 104 is the mean absolute error. Isn't it? 5, then 2 zeros, 4. Okay. 0.104 is the mean absolute error. Okay. So, what is it? True value or actual value we know, absolute error we know, and mean absolute error we got. Okay. Mean absolute error. So, true value is the mean value of all the measured values. Absolute error is true value minus measured value. And what is mean absolute error? Mean absolute error is the mean of magnitude of all absolute errors. Okay. It is the absolute errors. Just go for its magnitude and its mean. That will give you mean absolute errors. Okay. That is delta A bar. So, we will write it as delta A bar. So, we can write the expression as how much? How? Delta A bar is equal to delta A1. Delta A1 is the mean absolute, absolute error of the first one plus delta A2. And what is this symbol represents? It is the magnitude. Okay, only the value we are considering plus delta A5 divided by 5 or N divided by N, where N is the number of measurements. Okay, we can generalize like that. That is the mean absolute error. Okay, so actual value, true value, absolute error and mean absolute error. Next is relative error. So what is relative error? Relative error is mean absolute error by true value, or it is the ratio between the mean absolute error and true value of a physical quantity. So here we got the mean absolute error as 0.0104 ohm divided by how much? 3.02 ohm. 0.014 ohm divided by 3.02 ohm. What is this? 0.0104 is the mean absolute error and this is the true value. So the ratio between the mean absolute error and the true value, that is known as relative error. And if this relative error represented as percentage, and it is known as percentage error. It is the percentage error. Okay, so dividing this, we will get the relative error into 100 will give you the percentage error. Percentage, you know, representing as the 100. In terms of 100, we are representing, that is the percentage error. So we can write this as the equation delta A bar divided by A, where delta A bar is the mean absolute error and A is the true value. That is the relative error. And what is it? Delta A bar divided by A into 100, that is the percentage error. Okay, that is the percentage error. Okay, so relative error and percentage. So here, what is it? Relative error is equal to delta A bar, that is 0.104 divided by 3.2 is the true value. How much it is on dividing? We will get it is 0.034. Okay, changing the decimal position and all, it is 0.3. I have taken the first 3 digits. Then percentage error is this into 100. That is this into 100. How much it is? 3.4 percentage. It is 3.4 percentage. So what is our error here? Here the error is 3.4 percentage in this reading, in this experiment. From the true value or from the actual value, there is an error of 3.4 percentage. So how will you represent the result here? Here the result, that is here in this experiment, what is it? Resistance, isn't it? So we will write resistance is equal to 3.02, that is the true value, and from the what is the relative error, there may variation occur, how it is plus or minus 0.034. So from this there is a variation of plus 0.034 or minus 0.034 from the value. And in percentage, how can we write? 3.02 plus or minus 3.4 percentage. From this value, there is a difference. Plus value or minus value. How much it is? 3.4 percentage. From the true value, what is it? Either it may be plus 3.4 percentage or plus minus 3.4 percentage occur from the true value. Variation occur from the true value or from the absolute relative error, what is at 0.034. Okay, so that is the value, that's the resistance or the physical quantity. Here the physical quantity is resistance, so this is the resistance here. Okay, all the measurements, all the experiments, we can find out what is the error occur from your what is that, practicals, isn't it? Or from your experimental setup, you are taking the readings, and from the readings, from the true value, how much variation is occurring from each and every observations. Okay, so what is our aim? We have to reduce this percentage error. 3.4 no, it is little bit more. Okay, so you should be very careful while taking the reading. Okay, 0.1 difference on it. So if you are going for a second digit, second decimal, what is it? Least count is more. What is it? The error will be less. Okay, yeah, you are going for a what is that? 2 decimal position. So here you will get, instead of 2.8, you may be getting 2.91. Okay, 2.91 or 2.85. If you are getting like that, this we can reduce the error. Okay, so from a set of measurement, how will you find out the absolute error, relative error and percentage error? So before that, we have to write the expression, then we will discuss one more what is that, example. Okay, so you write down, you write what do you mean by absolute error mean absolute error, mean absolute error, relative error, relative error, and percentage error, and percentage error. Write down the arithmetic mean of, the arithmetic mean of, arithmetic mean, MEAN, mean of all measurements, all measurements can be taken as, can be taken as, can be taken as true value of, true value of the measured quantity. Arithmetic mean can be taken as the true value of the measured quantity. True value of the measured. Then write, if A1, A2, A3, etc. An are the n measured quantity, then true value is equal to A1 plus A2 plus A3 plus An divided by n. True value or A average. A average is equal to this. Okay. Then you write absolute error. Side heading you write absolute error. Absolute error. It is the difference between, it is the difference between true value, true value of the quantity, true value of the quantity measured. It is the difference between the true value of the quantity measured and the individual, and the individual measured quantity, individual measured value, and the individual measured value. You can write absolute error is equal to true value minus measured value, and write delta A1. Absolute error is represented by delta. Delta A1 is equal to A average minus A1. A2 is equal to A average minus A2. Then delta An is equal to A average minus An. Then next you write mean absolute error. Mean absolute error. It is the mean of the, it is the mean of the magnitude of, it is the mean of the magnitude of all the absolute error. Mean of the magnitude of all the absolute errors, all the absolute errors. Mean of the magnitude of all the absolute errors. So here absolute error, true value minus measured value, you can copy. Then it's already wrote. Then here what is it? Mean absolute error is equal to delta A bar. True value or average value, we can write it as A bar. Okay, instead of writing A average, I have written as A average. You correct it. It is write it as A bar, because all other places we are taking it as A bar. So delta A bar is equal to this two lines I said, it is only the represents the magnitude divided by n. Okay, so that is the mean absolute error. So the final result, we can write the final result as A bar, that is the true value plus or minus mean absolute error. So after getting the result, you have to write it like this: A bar plus or minus delta A bar. Okay, so write this. Therefore, the final result is equal to this. This is the final result. Then write relative error. Relative error. It is the ratio between, it is the ratio between mean absolute error to the true value. Mean absolute error to the true value. So relative error is equal to delta A bar by A bar, ratio divided by A bar. Okay. Then write percentage error. Percentage error. Relative error expressed in percent. relative error expressed in percent. That is, percentage error is equal to delta A bar by A bar into 100. Okay, into 100. So this is the absolute error, relative error and percentage error. Okay, so let us do one more example. Here we measured the length of a road. Okay, length of a road, road, using a scale, meter scale, and these are the measurements L1, L2, L3, L4 and L5. These are the measurements. So we have to find out what is the percentage error, what is the relative error, what is the absolute error, what is the relative error and what is the percentage error. So first what we have to find out? We have to find out the true value. Isn't it? True value, we can represent it as L bar. Isn't it? L bar. How will you get? It is the average of this. Isn't it? That is 2.48 plus 2.46 plus 2.49 plus 2.50 plus 2.48 divided by how many measurements are there? 5. Isn't it? So that is the true value, that is L bar. So how much it is? It is equal to 2. Find out, it is 2.48 meter. Add it and divided by 5. That is the true value or the actual value, average value, 2.48. Then next what we have to find out? We have to find out the absolute errors. Like absolute errors in each measurement. So I am writing it as delta L1. So in the first one, what is the absolute error? So what is delta L1? True value minus measured value. 2.48 minus 2.48. It is 0. What is delta L2? True value minus measured value. 0.02. Delta L3 is true value minus measured value minus 0.01. Delta L3 true value minus measured value minus 0.02. Isn't minus 0.02. And delta L4 is here. L5 is equal to minus 2.48. It is 0. Then what is it? Mean absolute error. Isn't it? That is delta L bar. What is delta L bar? Magnitude of the sum of the magnitude of this divided by number. So what is it? 0 plus 0.02 plus. Here it is negative. So we have to consider only the magnitude. So 0.01 plus 0.02 plus 0 divided by how many other? 5. Isn't it? So delta L bar is equal to this. How much it is? It's equal to, find out. It is 0.05 divided by 5 is equal to 0.01 meter. It is 0.01 meter. Okay. Then how will you write the correct length? What is the method of writing the result, expressing the result? So we can write length is equal to how much? True value 2.48 plus or minus 0.01 meter. Okay, length is equal to true value plus or minus mean absolute error 0.01 meter. Okay, the next we have to find out what? Relative error and percentage error. So what is it? Length is this. Then relative error is equal to what is it? Mean absolute error divided by true value. 0, 1 divided by, therefore percentage error. Percentage error is equal to 0.01 divided by 2.48 into 100 is equal to 0.40%. Simplify it, you will get it as 0.4%. Okay, so in this measurement, the percentage error is 0.4 and this is the length. Okay, so you have to represent it as like this: true value plus or minus the mean absolute error. Okay. One homework question in your page number, part 1 textbook, page number 25. Page number 25, example 2.7. That is the oscillation of a simple pendulum. It is a solved one. So you just copy the question and try to do yourself. Then if you are not, after getting the result, compare with the textbook answer. Okay, this is the thing. Here only the thing is you have to know addition and division. Okay, addition and division, that is the only thing you have to know here. So, and the equations. Equations are very simple. So you do it. Okay, and in between any doubt comes, you can call me. Okay, the next we have to go for the next one, that is the combination of errors. Combination of errors. Here we are measuring these two. Okay, measuring two physical quantities. For example, here the last example. The last example, that is resistance. Resistance we are getting by dividing voltmeter reading and ammeter reading, that is the voltage and current. So voltage and current are the measured values, isn't it? So if there is an error in voltage and if there is an error in current, that affect what is it, the final result, that is resistance. So here the resistance is giving us the ratio between voltage and current, isn't it? So how this, it is division. This value divided by this value give you the resistance. So if there is an error in both the quantity, how is it affecting the final result, that is for resistance. And we are adding, or what is it, total length we have to find out. First length is L1 and second one is L2. So the total length of a quantity is equal to what is it, L1 plus L2. And if there is an error in L1 and if there is an error in L2, how is it affecting it is R. That is, yes, you studied, that is a series combination of resistances. What is the resultant resistance? R is equal to R1 plus R2, isn't it? So if there is an error in R1 and if there is an error in R2, how is affecting the resultant resistance R? Okay, same way this difference. Say R is equal to, or T is equal to T1 minus T2. Final temperature is equal to T1 minus T2. So the initial temperature and final temperature. So if there is an error here and an error here, what will the error in the final reading? Okay, or powers we are finding, that is x square. A quantity is equal to x square. If there is an error in x, how the final result changes. So that is the combination of errors. Okay, so that is the application. These are the areas where we have to apply all these things. So two quantities, physical quantities A and B, where A is equal to A plus or minus delta A, where A is the true value and delta A is the mean absolute error, and B equal to B plus or minus delta B. B is the true value and delta B is the mean absolute error. So the resultant is Z, and what is it? It is the sum of these two quantities. Z is equal to A plus B. Okay. And what is Z? Z also we can write Z is equal to plus or minus delta Z, where delta Z is the mean absolute error in Z. So how is it? We know Z is equal to A plus B. So we can substitute for A and B. What is A? A is equal to A plus or minus delta A plus B plus or minus delta B. So rearranging this, opening the bracket, what is it? A plus or minus delta A plus B plus or minus delta B. Again taking this A and B together, A plus B plus or minus delta A plus delta B. Okay, plus or minus is common here, that is taken outside. So put this inside the bracket and this inside the bracket. So comparing with this, Z is equal to A plus B, and what is delta Z is equal to delta A plus delta B. So what is the resultant error? The resultant error will be the sum of the individual errors. Resultant error will be the sum of the individual errors. So while adding two physical quantities, the resultant error, the error in the resultant quantity will be equal to the sum of the individual errors. So that is the first result. So you write. Question is, how can we estimate the error in the sum and difference of different physical quantities. Sum and difference of different physical quantities. Sum and difference of different physical quantities. You can write A, you can copy this up to here, that is delta Z is equal to delta A plus delta B, right up to here. Then write when two quantities are added or subtracted, when two quantities are added or subtracted, the absolute error in the final result, is the sum of the absolute errors in the individual quantities. 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 So the same thing will come for this minus also. That is why I am not writing it here. Here A minus B comes. So here minus comes and here also minus. So we are taking this A minus B here. Then plus or minus delta A plus delta B. So in the difference also, what is it? Delta Z is equal to delta A plus delta B. Okay, so while adding, what is it? The error also you have to add. That will be the error in the final result. Next we can see the product. Okay, that is Z is equal to A into B. A quantity, physical quantity, is the product of two physical quantities. What is it? V is equal to IR. Let's an example. V is equal to IR, or distance is equal to velocity into time. So distance is the product of velocity and time. So such cases comes, how will you consider the error? So what is it? Z is equal to A plus B. So we can write Z plus or minus delta Z is equal to what? A plus or minus delta A into B plus or minus delta B. Then multiply it. Open the bracket. So it comes AB plus A delta B plus or minus. Then plus or minus delta A B. Then what? Plus or minus delta A delta B. Okay. AB A plus or minus delta B. So plus or minus A delta B plus or minus A delta A B, and last term is plus or minus delta A delta B. Okay, so after multiply this, opening the bracket, we will get it like this. Then divide this whole equation by AB. The whole equation by AB. So what will you get? Here it is Z and delta Z. So instead of AB, we can write it as Z. So Z plus or minus delta Z divided by Z is equal to AB plus or minus A delta B plus or minus delta AB plus or minus delta A delta B whole divided by AB, because AB and Z are equal. Then what is it? 1 plus or minus delta Z by Z, isn't it? Z by Z is 1 is equal to AB by AB is 1 plus or minus, here A and A get cancelled. So what is it? Delta B by B plus or minus, here B and B get cancelled. Delta A by A plus or minus delta A delta B divided by AB. Delta A delta B divided by AB. And look at the last term. Delta A and delta B are too small. So we can neglect this last term. Okay. So product also too small. So what comes? 1 plus or minus delta B by B plus or minus delta A by A. Then compare the equation. 1, 1. So what is remaining? Plus or minus delta Z by Z is equal to plus or minus delta B by B plus or minus delta A by A. So what can you write? We can write delta Z by Z is equal to delta A by A plus delta B by B. Delta A by A plus delta B by B. So what does it says? It is the relative error, isn't it? So it is the relative error. So the relative error of the result is the sum of the relative errors of the individual quantities. Okay, relative error of the result is the sum of the relative errors of the individual quantity when we are finding out the result as the product of two physical quantities. The same thing will be there in the case of the division also. If you are dividing, then also this is the result. Okay, so write down the next question. How can we estimate? How can we estimate the error in the product and quotient? Error in the product and quotient of product, quotient and power. You add that also for product, quotient and power of different measured quantities. Power of different measured quantities. So same thing, you have to copy this till this, then write. After copying this up to this, you can write when two quantities are, after completing this, okay, when two quantities are multiplied or divided, the relative error in the result is, the sum of the relative errors in the multipliers. multipliers, multipliers. Okay, so for division and product, it is this answer. And next, if it is power, see, Z is equal to A square or Z is equal to B square. What is it? How can we write? Z plus or minus delta Z is equal to, what is A square? It is A into A. So we can write A plus or minus delta A into A plus or minus delta A. Okay, and we already studied here what is it? The product. Here the product of two quantities. Here it is the same quantity, that is the difference. So what will be delta Z? Delta Z by Z. Delta Z by Z is equal to delta A by A plus delta A by A. A by A. If it is delta B, it is B delta B by B. So what is delta A by A plus delta A by A? It is 2 delta A by A. If it is B, how will you get 2 delta B by B? Okay. So what is it? It is square. So it is 2 times of the relative error. If it is 3, it is 3 times of the relative error. If it is n, it is n times of the relative error. N delta A by A. If Z is equal to A raised to n. Okay. So it is the product of the power and relative error. So write down. Write up to this. Then write the after copying this. Okay. The relative error in a physical quantity, the relative error in a physical quantity raised to the power k, raised to the power n, not k, raised to the power n is the n times the relative error in the individual quantity. N times the relative error in the individual quantity. Okay. Delta Z by Z is equal to n into delta A by A. In your textbook it is taken as k, no problem, any variable. Okay. So a combination of errors by adding or finding out the difference, product, quotient and powers. Addition and division, subtraction, what is it? It is the error is the sum of the individual errors. And in product and quotient, what is it? Relative error. Relative error is the sum of the individual relative errors. And to the power, what is it? It is the product of power and relative error. Okay. So problems we'll discuss later. Complete your notes, and that's all for today. Thank you.